Hello everyone. Today will be doing the second part of force, which has two parts, basically subparts. One is center of gravity and the second part is centripetal force. So now we'll start with the section center of gravity. Keep your classwork ready and here we go. Today, right now, we'll be doing the first part of the second section of force, which is center of gravity. Now, whenever this word comes to you, this word you have heard a lot of times in last 3-4 years because you are studying physics and you have heard about it, that center of gravity and everything. Now, what does practically it means? It means that every extended body, like say me, you, anyone, any object, maybe this pen, this board marker, this object, it has got a weight. Now how we calculate the weight? We weigh it in some beam balance or spring balance or something. But how we can actually find out that where is the point in this extended body where the total weight can actually work, and that will be the point where the total weight will be concentrated. Because this is an extended body, I don't know exactly through which point the weight is acting, and if I can find out, then I can even hold this pen with my finger. If I can actually press it at the center of gravity, then we can actually make it to stay on my finger. Even any extended object, you can do that if you can find out the point where through which the whole weight of the body is acting. That means the center of gravity, if you can find out. Isn't it very interesting? So now let us see how it works now. Suppose we have an extended body and we have several point masses. That means we have this body is having a mass, and this mass is actually the sum of innumerable number of point masses. You can imagine how many points can it can contain, right? So say I'm giving you an idea. In a way, we have heard about we take pictures through our mobile phones, and there we are habituated with few terms, like we know what is HD. HD means they write 1920 by 1080. Now what these numbers signifies? It signifies that these many lines, if I can draw in that rectangle, that 16:9 rectangle that we are taking the snap, then we can draw these many number of lines horizontally and vertically. So this way we will get several intersection, because this line will get intersect with each other. So those points, there will be so many number of points which will ultimately define the whole picture. So here also we have several point masses which will ultimately form this body. So we have taken few out of this innumerable number of point masses. We have taken only 7 points, and each of these point masses, they have individual weights. So W1, W2, W3, W4, W5, W6, W7. These are the distribution of the weights on this extended body. But the total weight of the body will act through a point where the total weight is concentrated, and this point, my dear students, this is called the center of gravity, the center through which the total weight of the body acts. Now what is the physical definition? We have understood what it is, I hope. Sure, we have understood what what this means. We can now visualize what center of gravity is. But what is center of gravity? How we can define it in our scientific words? The very simple. You already have done the moment of force, the turning effect and all. Suppose if this is an extended body and there are so many weights mean force, they are acting, and we have a point where the total weight acts, and we can hold that body in that particular point. Okay, sure. So in this, among all these weights, they are individually forming some perpendicular distances with respect to G. So all of this, they have individual moments and they have a turning effect. Like W4 will make it turn like this, W3 will make it turn like this. This is clock, this is anti-clock. So it is trying to make the body to having a turning effect, but the body is at rest. then only we can calculate the weight. Okay, so we usually don't calculate a weight of a body which is moving, usually don't. Like in later on in higher classes we'll come to know that there is not even any, the mass we say, that is a rest mass. If a body is moving, then we cannot calculate the mass. When we go into the atomic level, we have quantum physics, there you can understand that we have masses called rest mass and dynamic mass. Okay, we are diverging from our point. So center of gravity, so we can actually find out several moments of force which are giving a turning effect, but ultimately the body is at rest, so there is no change, there is no turning effectively. So what I can say, now comes the definition. What we can say, center of gravity is the point on an extended body. Please do write in your classwork. Center of gravity is a point on an extended body of finite mass where the total moment of forces or weights, total moment of weights of the individual point masses, total moment of weights for the individual point masses with respect to a particular point is equal to 0. So it is a point, the definition is over. So it is a point where the total net moment of all these weights which this body can have, as many number of weights you can imagine, all the moments of these weights will become 0. That is called the center of gravity. Okay, now in our syllabus we have to know the definition, we have to visualize what center of gravity is. That part is over. And next thing that is very important, that is we have to know the center of gravity for different types of bodies. And now we will see how the center of gravity is located for different types of extended bodies like sphere, cone and all these things. Okay, here we can actually see, as I was telling you, that we have to remember a few things, few center of gravities for some extended bodies. And you can see these are all geometric bodies. They have a particular shape. They are not irregular, they are regular shape. So we are starting with a circular ring. You can see the ring is having a center of gravity at the center of the ring. We have a circular disc where also the center of the disc is the center of gravity. We have triangular lamina, and for that the intersection of the medians is the point through which the center of gravity acts. For rectangle, it is the intersection of the diagonals, even for parallelogram, even for square. And then we have a rod. If it is uniform, at the midpoint of the rod we can get the center of gravity. And for cylinder, it is the midpoint of the line joining the centers of the two circles on the top and bottom of a cylinder. So you can see these diagrams, and you have to write this. You can also have a solid cone. You'll find it in your textbook. And for solid cone, the height, the center of gravity is at 1/4 of the height of the cone. And if it is a hollow cone, then it is 1/3 of the height. These are some regular facts that you should know. You will find out there will be in your textbook, there will be some objects written and their center of gravities, and you also have these diagrams. And in your board exam, they can actually ask you to write where the center of gravity lies. Along with, you may have to draw a diagram like this. You can see the diagram, you can see things, except the hollow cone and solid cone. You can just draw it. It's not a big deal. In your classwork, please copy these diagrams and do mark the center of gravity and do write the position of center of gravity in your classwork. It will help you. Okay. Now we'll move into a section where we can actually find out the center of gravity for an irregular object. I mean, not having any particular geometrical shape. Okay. Now check it out. So now how we can calculate the center of gravity for an extended body of irregular shape. we already know the different geometrical position of the center of gravity for different geometric shaped object, like whatever we did just now, we have gone through. But right now we have an irregular body. So how we can calculate the center of gravity? That experiment you can even perform at in your place, in your home. It's nothing. You just take any irregular body, but try to make it thinner. Don't make it much thicker. That will be a bit problem. So if you can take some irregular paper or something, that will be very good. So what we do, we just make 3 holes, like what we did. We did 3 holes, A, B and C. Okay. So from A, you just put it somewhere in vertical. Okay, some cardboard or something, whatever, or some soft place where you can actually hold the body, nothing else. So now it's a nail or a pin or something. You do one thing, you just make it hold the body like this and take a plumb line. Now what is a plumb line? Plumb line is basically a string, and at the end of it there is a heavy object, but it should be usually conical. That's called a plumb line. But otherwise you can just take some weight which is heavy and just take a string of jute or something and just tie it, and from that nail you just hang that plumb line, so it will fall like this. Sometimes for some moments it will oscillate, and after some time, since it is hanging like this, so it will stop. And then on the plumb line, with some pencil or some chalk dust or something, just give some trace of the plumb line, and then remove it and draw the straight line like I have drawn AD. Okay, now forget about A, go for B. Now make B here. Again you drop the plumb line, you will get something at E. Again you will get a point here, and again make C here, and again you will get a point F. Now we have already drawn 3 plumb lines. Okay, for 3 positions, for A, for B and for C. So we have 3 plumb lines. We have 3 image, or the trace of 3 plumb lines. So now these 3 plumb lines will definitely pass through a fixed point. Like here it is this point. Okay, so this point is the center of gravity for this particular extended body. So in this method we can actually find out any irregular object. But if it is lamina, then it will be much easier for us. If it is a very thick object, then it will be a bit difficult, because we have to continue. Like here we have done for 3 holes. Then for if it is very heavy and it's not very thick, then maybe we have to go for even 9, 10 or maybe 12 number of plumb lines, and then we can locate the center of gravity. Because it is, when the body is very extended, then we have, for accuracy, we should take more number of plumb lines. But if this body is like this, a small one, a paper, but is having a regular shape, so then we can just follow this method to find out the center of gravity. And eventually, I hope you have understood, or I hope you have noticed one thing, that when we are dropping the plumb line, we are attaching a weight. So that means that plumb line is always vertical. That means it is always showing the total weight of this particular body or this particular hole on a vertical motion. So for B also the same thing happens, for C also the same thing happens, and finally when they intersect at the same point, that point becomes the center of gravity, because that point is actually showing you that moment of forces through all the weights acting through A, B or C, they are cancelling each other, because this body was not moving, even the plumb line was at rest when we took the trace of it. So net moment is 0, and that's why this is the center of gravity. Alright, great. Now this part is over. There are very easy questions at the end of this section. Solve them. I will come up with your doubts in our AccentUs WhatsApp group. But now I'll move into the next part, which is circular motion and centripetal and centrifugal force, mainly centripetal force. Okay, so let's check it out and do perform this experiment at home. It will be a fun for you. Okay, you can actually find out and we see where the center of gravity lies for an irregular kind of object. Alright, now let's move to centripetal force. So now we are into the next part, is centripetal force. you can see uh, whenever a body revolves in a circle, that means we are doing a circular motion, and the body revolves with a constant speed, that is v mentioned here. I'm telling you constant speed because at each and every point the direction of this speed, I mean this velocity, it changes. So the magnitude of this velocity remains constant. So actually we can say it is uniform speed. You did it in class 9, uniform speed diagram. That thing again is coming up. And whenever a body of mass m is revolving in a circle with a uniform speed v, and the magnitude of velocity is v with a radius small r, then the centripetal force, which is always connects the body towards the center of the circle, so it binds the body towards the center of the circle, is called centripetal force, and this value is mv square by r. And any force can be a centripetal force, say for gravity, which connects the planets, the moons, the stars and all, like we are connected to the sun, moon is connected to the earth, like this. Even the friction, when a car is turning, on a road, then also the friction provides the necessary centripetal force so that the car doesn't slip or goes away from the track. Or even the tension, as you can see in this diagram, person is revolving a ball around it, so that tension in the string is the centripetal force. Or when we are taking a loop, you can see in the diagram we are taking a loop, then even the weight, the downward weight can act as the centripetal force. That is the representation of centripetal force, always towards the center of the circle in which the body revolves. Okay, now let us check other things in about centripetal force. I'll be explaining to you the same thing. Okay, keep your classwork ready. This is a very simple diagram that you have drawn in class 9. The circular motion, uniform circular motion. A particle is moving with a constant speed. I mean the magnitude of the velocity is constant. Why I am saying that only magnitude is constant, because you can see the velocity at A is like this, and when we are moving to this point, the velocity at B is like this. It is tangential to each and every point. So I can understand that the direction of velocity is changing, and when the direction of velocity changes, whenever velocity is a vector quantity, it has magnitude and direction. So if magnitude changes, then the velocity is changing definitely. But if it is not changing its magnitude, but it is changing its direction, then also we have the same thing, and that is we have the change in velocity. And what happens when velocity changes? Eventually another physical quantity comes into the picture, and that is called acceleration. So in this case, in this type of motion, whenever the direction of velocity is constantly changing, and that's the reason why it is following this circular motion, and due to this there will be an acceleration generated which will try to make this body or particle to be bound at the center, and that binding acceleration, or that acceleration which will bind the object to the center, is called centripetal. Centripetal is a Greek word. Okay, centri means towards the center, centripetal means towards the center, towards. So towards the center. So if I try to draw what is the centripetal acceleration here, it is like this, and the direction at this point will be like this. AC depends, means centripetal acceleration, and the value is, if the mass of this body is m, then it is called, the centripetal acceleration is v square by the radius, which is r, and if you want to find out the centripetal force, that is mv square by r. Centripetal force are very important because it actually binds a lot of things. As I was telling you, that even the gravitational force of attraction between the stars, planets and the satellites and everything, like we are attracted, we are bound to the sun, and that's why earth is revolving, and again the moon is revolving around the earth because the moon is bound to the earth. So these kind of things, they all are dependent on this centripetal force or centripetal acceleration. This gives rise to centripetal force. Of course, you can understand mass into acceleration is force. So this is the concept of centripetal force that we were talking about. Okay, and do write, these expressions are not included in class 10 syllabus. This is there later on when you go in higher classes, but for the sake of information, please do copy this expression in your classwork. Okay, now let us move into another part called the centrifugal, which is a counterpart of this kind of centripetal. Let us discuss that right now. We actually found what was written in the scroll, that centripetal and centrifugal force both exist and they are the action reaction phase. In class 9 we actually did this, Newton said that in the third law that to every action there is an opposite and equal reaction. Action and reaction, they act on two different bodies. It is the thing I was showing you, it was a fun, but actually centrifugal, what is centrifugal? Whenever I was telling you from using this diagram that something is making the body to be bound. Now, this perspective is a perspective when you are seeing the whole motion from outside, like I am observing this motion. So I can see, okay, fine, there is an acceleration which is binding this towards the center, centripetal acceleration and everything. Now comes the centrifugal acceleration or centrifugal force. What does it mean? If I actually make myself to go at point A and I am revolving in a circle, then what we feel? We actually don't feel that we are bound to the circle. We actually feel that there is some force which is making me away from the circle. This experience, you have taken a lot of rides, say in any fun park, like in Kolkata we have Nico Park. In those rides, even the Disney is the fun park, the theme park they have, they are actually selling you the centrifugal force. They are actually selling you the feel of centrifugal force. Whatever ride you take, if you are taking a loop like this, you are taking a loop, when you are here, some carriage is taking you here, your weights are downwards, and when you are sitting here, you'll feel that you are falling down, but you won't. First of all, you are locked, and second, this whole thing is under control. It is having a center where it is bound. So you are not going to fall, but you'll feel that you are going to fall, and that feeling is called the centrifugal. Okay. So Newton said that centrifugal is a pseudo force on fictitious. Now what does this pseudo? Pseudo means which is not actual. So I am telling you another example. Suppose you are sitting inside a car and the car is accelerating. You'll see that you will feel a force backward when the car is accelerating, and when the driver is applying the brake, you lean forward. So you have heard that this is because of inertia, but this is actually the nature of pseudo force. That means when the car is accelerating forward, since you are inside the car, you are inside the system, you are not outside. From outside, the person will see, okay, the car is accelerating, but what you are feeling a force backward. That force is a pseudo force. Similarly here, when we have a centripetal acceleration, we also have a centrifugal which is away from the circle, and this force is called the centrifugal force, or the acceleration is called the centrifugal acceleration. And this is what I said that this is pseudo. That means this is non-existent actually. So in real life, in real point of observation, this force doesn't exist. But when we are actually within the system, we are making ourselves free from all other parameters, and that's why at that point of time we can experience that particular pseudo force or that pseudo acceleration, and that is the fun or the adventure of those rides we always look for. Okay, fine, we'll go and take that ride, like in nearby, whenever there is some kind of fair or kind of thing, you have those giant wheels, we ride on it, and we actually feel that thrill of centrifugal force, that fill. Okay, we sell, or this theme park, they sell the that thrill of centrifugal. So this is the concept. So basically centripetal and centrifugal, they are similar thing as per their magnitudes are concerned, but the direction and the perceptions are different. Centripetal exists when we are observing the motion from outside. Centrifugal, I repeat, centripetal exists when we are observing a motion from outside. Centrifugal exists when we are observing a motion within the system. That means we are within the system and then we are observing the system. Then we will face or will experience certain amount of force or acceleration or some vector which are pseudo, which are actually non-existing at reality. But this exists due to our own perception when we are within the system. You see, we observe the system, but when we become the part of the system, then this pseudo comes and then this centripetal acceleration comes, since there is a centripetal acceleration. This won't come just like that. This exists, that's why this exists. Please remember this. Okay. Now I will tell you another example and I'll finally wind this class of centripetal and centrifugal. The example is very interesting. All of us, we have at our home, we have a washing machine mostly. So in washing machine, after it is washed and all the rinsed and everything is done, at last we give it to a dry one. So when we make the clothes dry, what happens? The tub what is there, it rotates at very high speed. So whatever water molecules they are stuck to the clothes, they experience, since they are loosely held particles, they are sitting on a system which they don't belong to. So whenever that spins at a very fast rate, those water droplets, those water molecules, they experience a centrifugal force and they move away from the clothes, and finally that is being drained out from the washing machine, and finally when we take out the clothes, it is apparently much more drier than it was before. It is not completely dry, but it is much drier. I mean, the water molecules are less because we have rinsed it, we have drained it out using that centrifugal concept. This is a very good example of existence of centrifugal force in our daily use. Okay, so this is what I wanted to tell you about the center of gravity and the centripetal and centrifugal. These are the few concepts you have to remember. Go through the textbook and there are few examples and few question answers at the end of this section after center of gravity as well as in the centripetal force. Just go through this, solve those examples and solve those question answers. Later on we will be having a doubt clearing session in our AccentUs WhatsApp group, and there we will solve our doubts. Okay, so this is it. So this way the chapter force is over. This was the part 2. In the previous part we already did the moment of force, turning effect and all these things, and this is the second part, so we have completed it. Okay, so now it's your turn. Just solve the question answers and all. If you have any doubt, please tell me in our AccentUs WhatsApp group. Okay, so till then, bye bye, stay safe and wash your hands at regular intervals. Whatever guidelines, health guidelines are given, please follow them and don't waste time. Use this ample amount of time and to improve yourselves, study more and practice more so that you will be very much at par with the board exam on 2021. Okay, all the best.